Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. In today also, I'm going to discuss about a very important topics of the concrete. Rather, I will discuss about a concrete ingredients. It is a cementitious supplementary cementitious material, that is microsilica. What is microsilica? What is the IS code? How it is produced? What is the doses? What is the requirement? And of course, why the microsilica is used in the concrete? In the video, I will discuss each and everything in details. And if you are new to my channel, and subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the microsilica है क्या? ये चीज़ क्या है माइक्रोसिलिका, वो हम लोगों को जानना क्या है. तो बाय डेफिनेशन माइक्रोसिलिका also known as silica fumes in an ultrafine amorphous non-crystalline powder composed primarily of silicon dioxide. So ये क्या है? ये एक सिलिका फ्यूम है. तो इनका प्राइमरी कंपाउंड क्या है? सिलिकॉन डाइऑक्साइड, दैट SiO2. नाउ ये कहाँ मिलता है? व्हाट इज द प्रोडक्शन प्रोसीजर और कैसे हमको मिलता है? दैट इज अ बाय प्रोडक्ट ऑफ द फेरोसिलिकन एंड सिलिकॉन मेटल इंडस्ट्रीज. नाउ ये एक बाय प्रोडक्ट है. जो भी हम बाई प्रोडक्ट कोई भी कंपनी को कोई भी प्रोडक्ट का जो भी प्रोडक्शन प्रोसेस का जो बाई प्रोडक्ट है यूज़ करते हैं, तो क्या होता है ना, ये बाई प्रोडक्ट यूज़ करने से हमारा जो इन्वायरमेंटल सस्टेनेबिलिटी वो हम लोग को हेल्प होता है. क्योंकि अगर हम लोग यूज़ नहीं किया तो इट विल बी डिपोजिटेड ऑन द अर्थ, और अगर अर्थ में डिपोजिटेड हो गया तो अर्थ का पोल्यूशन हो जाएगा. तो फर्स्ट थिंग्स वी आर making our environment safer and we are using for the environmental sustainability. Now ये बाई प्रोडक्ट कहाँ आता है? फेरोसिलिकन और सिलिकॉन मेटल इंडस्ट्रीज. इसका मतलब क्या है? जहाँ फेरोसिलिकन एंड सिलिकॉन मेटल इंडस्ट्री है, उधर जो बाई प्रोडक्ट प्रोड्यूस होता है दैट इज माइक्रोसिलिका. Produced during the high temperature reduction of quartz with coal and electric arc furnace, and the fumes are captured and collected by filters condensed into silica fumes. तो क्या होता है ना, इसमें हाई टेम्परेचर में क्वार्ट्ज को कोल के साथ इलेक्ट्रिक आर्क फ्यूम फर्नेस में जब बर्न किया जाता है तो फ्यूम्स क्रिएट होता है. ये फ्यूम्स को कैप्चर करके कलेक्ट करने के बाद फिल्टर करने के बाद कंडेंस होता है और उसके बाद सिलिका फ्यूम क्रिएट होता है. तो सिलिका फ्यूम कहाँ क्रिएट हुआ? तो सिलिकॉन और सिलिकॉन इसका अपीयरेंस कैसा है? ग्रेस एक्सट्रीमली फाइन पाउडर per kg. ये स्पेसिफिक सरफेस एरिया इज ह्यूज. तो हम लोगों ने कंक्रीट जब हम सीमेंट के बारे में डिस्कस किया था, ये स्पेसिफिक सरफेस एरिया क्या होता है ना, कंक्रीट का जो सीमेंट का जो स्पेसिफिक सरफेस एरिया ज़्यादा होता है वो रेट ऑफ रिएक्शन ज़्यादा हो जाता है. ज़्यादा एरिया कवर करता है तो ज़्यादा आपका रेट ऑफ रिएक्शन और रेट ऑफ हाइड्रेशन भी ज़्यादा होता है. तो ये मान लो इतना है, तो इसका आप सोचो जी इसका रेट ऑफ रिडक्शन क्या, रेट ऑफ रिएक्शन विद सीमेंट एंड विद द वाटर कितना हो ज़्यादा हो जाएगा, तो फास्टर स्ट्रेंथ हो जाएगा और ईजी हो जाएगा. देन आइस कोड प्रेफरेंस ये हमको जानने का है, दैट इज 15388 सिलिका फ्यूम. हमको अभी जानने का है कि ये जो माइक्रोसिलिका है इसका केमिकल एंड फिजिकल प्रॉपर्टीज क्या है. तो एज पर Table 1. In the table 1, it is described what will be the chemical requirement. So chemical requirements क्या है? See, main composition of microsilica is the SiO2 और the silicon dioxide. तो कितना होना चाहिए परसेंट बाई मैक्स? दैट मिनिमम 85% होना चाहिए. अगर 85% के नीचे है SiO2, that means it will not be considered as microsilica. Then moisture content percentage by mass maximum 3%. 3% के ज़्यादा हो जाएगा तो it will not be considered as microsilica. Loss of ignition, that is 4% max. Alkalis as N2O present in the max 1.5%. तो इसको और भी नोट्स दिया है. For determination of moisture content, dry a weighted sample at received and constant mass at an even 105 degrees centigrade to 110 degrees centigrade. Requirement of limiting alkali shall be applicable in case silica fume is to be used in concrete containing reactive aggregate. So what is the reactive aggregate? That is sometimes in the aggregate some reactive parts and it is reacting with the silica, and that called the alkali silica reaction. And that what is alkali reaction, why it is important, what is the detrimental effect on the concrete, I have made again a detailed video. You will find out in the description box. Please check and you will get the full information. And then determination of alkalis method test. Now in the ISO 15388 in the table 1, what we discovered about the chemical requirement. Now what is the physical requirement? That is given in the table 2. So what I discussed, specific surface area, that is the criteria for the cement. That here also you need to find out meter square per gram, that is 15 and 7 days as present in the control sample, that should be 85. And here it is saying the C note 3. What is in note 3? In the test method of determination of compressive strength of silica fumes cement mortar in accordance with IS 1727, the value of factor N may be taken as 1. Okay, so compressive strength is the huge, that is in this 85. That is why when you are using in the high strength, we are easily can find out the high strength, or easily can achieve the high strength. So it's become the physical and chemical properties as per the IS 15388. The next part is mixing percentage of silica fumes in the concrete. So it is very much useful, but it should be used like a salt, because if in the gravy, in the cooking, whenever you are using more salt, that dish you cannot take, because it is not usable. So in the same way, the microsilica also to be used in a very controlled manner and in the little percentage. Otherwise, it will give the degradation effect. So what is the typically used at 5 to 15% by weight of cement, but as code is given the provision up to 10%, but you can go up to 15% as per your project requirement or the strength requirement. And it is the common mix proportion: 5% for general durability movement, 10% for marine or chemical environments, and 15% for high performance concrete. Expert is what is the role of microsilica in concrete. That we need to know why we will use microsilica as a cementitious supplementary cementitious material. So first is the filler effect. Microsilica particles fill the void between the cement grains, increasing packing density. Now ये क्या होता है ना, हमारा concrete क्या है? Concrete is the big 20 mm aggregates, 10 mm aggregates. तो क्या होता है ना, 20 mm aggregates के अंदर जो voids होता है वो 10 mm aggregates से fill होता है, और 10 mm aggregates के जो voids होता है वो हमारा जो packing होता है sand में fill हो जाता है, और उसके बाद हम concrete में करते हैं cement homogeneous and मेटल बनाता है, जिसको हम बोलते हैं concrete. But what is microsilica? Its surface area is more, and it's the finer particle. Again, is the micro void that is also filled by this microsilica. So the packed density of the concrete is increased. So reacts with calcium hydroxide to form additional calcium silicate hydrate (CSH), which increase strength. Now, what is this? We have the cement compound in the cement itself, C3S, C2S, and these are the two components primarily responsible for the strength gain. Now for the early strength gain, C3S within the 7 days, and from 7 to 28 days, C2S. So what is the chemical reaction when we are using cement, when we are adding water into the cement? I have made a detailed video. You can check in the description. You will get the full chemical reaction or chemical reaction with the cement and the water. But here what is happening? First, C3S, when it start reacting with the water, it produces the CSH gel, which is giving the strength. But again, whenever this reaction is happening, they produce 3 molecules of calcium hydroxide. Now, what is the use of this calcium hydroxide? It is no use. What is happening? This calcium hydroxide, what is happening? It is react with the water and it becomes soluble, and it make the concrete porous. और अगर concrete porous हो गया, क्या होगा ना, हमारा जो harmful chemicals like chloride, like sulfur, carbon dioxide, that will penetrate inside the concrete and it will corrode the steel, as well as it will deteriorate the concrete itself. So what is happening? We need to remove this calcium hydroxide from the concrete in order to make our concrete non-porous. So what is happening? We are using the GGBS or using the fly ash. They both have the SiO2. And what is happening in this SiO2 in the form of microsilica also is the main component. Is the 85% is silicon dioxide. Now this silicon dioxide, what is doing? They are reacting with this calcium hydroxide, and what they are producing? Again, they are producing the CHA gel, which is the main reason to gain strength. So what is happening? C3S also reacting and produce CSH gel. C2S also producing reacting and CSH gel. And what is the byproduct? What is the product? It is calcium hydroxide, which is harmful for the concrete. Now using the microsilica, the silicon dioxide also reacting with SiOCaOH calcium hydroxide, and they are again producing the CSH gel, so which increasing the strength. That is why microsilica is very much important in the concrete for the high strength concrete, because it increases the strength. Now it's improved durability. How? Reduces permeability. Why? Because again this calcium hydroxide, which is making the concrete more permeable, then these SiOs, the silicon oxide in presence in the microsilica react with the calcium oxide, which is cannot make with the water and make the soluble one. So what is the improved durability? It's better chloride resistance, chemical attack resistance, and freeze thaw cycle. So it's using the microsilica we have the effect on our chemical reaction that already discussed. That is the primary reaction is pozzolanic reaction. When microsilica reacts with the free lime, that is the calcium hydroxide, as we discussed, that this calcium hydroxide is free lime is producing with when C3 is reacting with the water. Now SiO2 plus calcium hydroxide CSH gel is this gel is the reason for the strength gain. Concrete that increasing binding gel, that is which provides the strength, that is CHA gel. So this is the chemical reaction is happening when we are adding microsilica into the mix. Now the next part is advantage, disadvantage, and the limitation. So what is the advantages? The advantage is increasing compressive strength up to 25%. That is what is the number one choice for the high strength above 600. It reduces the permeability, either water tanks, marine and bridge structure, then enhance durability, resist acid, sulfate, and climate, and improves what's ideal for repair mortars, and reduces bleeding and segregation. Now, bleeding and segregation is very much harmful for the concrete. So when we are doing the concrete, this phenomenon can happen. But using microsilica, we can reduce the chances of bleeding and segregation, because it's the high face area of the surface area, and it is reacting with the more area, and also it is the micro-wide. Okay, the advantages. So everyone has the two sides. It cannot only have the advantages. It must have some disadvantages. So we need to discuss what is the disadvantage. It is expensive compared to other additives. Now it is why it is expensive, because it's a byproduct also, but it can be used other areas. That is why it's expensive to other additives. And high demand really needs super plasticizer, because it's surface area, specific surface is more, so the rate of reaction is more. That is why the water demand is more. So if the water demand is more, you need to add more water into the mix, and if you add more water into the mix, water cement ratio will increase, and if the water cement ratio is increased, it is not good for the concrete, because it will weaken the concrete and the strength will not achieve. So that is why whenever you are using the microsilica, we need to super plasticizer, and it's a rapid setting, requires good control of curing, otherwise rapid setting happen, because the rate of hydration or reaction is more and difficult to handle, very fine powder prone to airborne dispersion. So it should be to handle with air, because it's a very finely powder, so it can be airborne dispersion. So in the air it can be. Now it's become the disadvantage. But what is the limitation? You cannot use more than 10 to 15% of the in the mix. One overuse can lead to brittleness of the concrete. So if we are using the excess amount, the concrete will be brittle, and what will happen? We are not getting the strength, and needs uniform mixing. Poorly mixed microsilica can reduce its effectiveness, and not always locally available. That is also another limitation that we are not getting. But nowadays, as it is widely used in the concrete, now in every corner of the country it is available. So these are all about the microsilica, and I hope you find it useful. So summarize what is microsilica and how it is produced, physical and chemical properties as per IS 15388 2003, mixing percentage of microsilica in concrete, role of microsilica in concrete, chemical reaction, and advantage, disadvantage, and limitation. And I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you'll get immediate notification. And I'm waiting for your valuable comments so that from your comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching.